Okay, so let's take a look at 3-6. 3-6 is a chain rule. We are going to be talking about how do we deal with a function that has a function locked inside of it, so a composition. At this point, on that 200 question derivative paper, I've avoided all the problems that were a chain rule because we didn't have that information. We had no way to fix if we had a function that was locked inside of another function. Example, if I have the square root of x squared plus 2x minus 5, up to this point, I had no way to take the derivative of that. I've not taught you how to take the derivative of that. You would have just went, I don't know. So we need to know how to do those types of functions. So this is our next fact that we have to learn how to do, okay? So the chain rule basically says that if we have a function g of x locked inside of another function, you take the derivative of the outside stuff and you leave the stuff there, but then you have to multiply by the derivative of the stuff. Okay, so leave the stuff, but then multiply by the derivative of the stuff. The stuffing. So to differentiate a composite function, you have to identify what's on the outside, what's on the inside. Take the outside derivative using the rules we already know. Leave the stuff there. Then we multiply by the derivative of the stuff. Okay? So I always think of it as take the derivative of the outside, leave the stuff there, multiply by the derivative of the stuff. The thing that people love to forget is to leave the stuff there in the original part. Pass one to her. Take one, pass it over. Take one, pass it over. You're welcome. Up on the board in blue is your next flashcard. You need to write the chain rule on it. You need to know the chain rule. The chain rule is super important. I know. I had to wake it up. Don't be big babies. It'll come back. G of x, yeah. Times. Yeah. Just in blue there. Just one of them. Yes.
Do I need to write front and back?
No. So it's going to be f prime of stuff times the derivative of the stuff. We're going to take the derivative of the outside function, leave the stuff there, and then we're going to multiply by the derivative of the stuff. Yep, yep. So let's take a look on the board of this example. So the stuff is our g of x. The outside function is a power, an n. So what happens to any power function? The power drops down in front, the power goes down by 1, the stuff stays there. But what do we have to multiply by? The derivative of the stuff. Okay, let's say that again. For a power rule, the outside function is the power. So if you have stuff stuck in a power, you're going to drop the power down in front, power goes down by 1 just like normal. Leave the stuff there. Multiply by the derivative of the stuff. Okay? I do. I know. It's my job. Okay. So next, what we're going to do is we're going to rewrite this function, getting it ready, just like we did for regular functions. We're going to write that stuff to the 1/2 power. So our inside function, our g of x function, our stuff is x squared plus 1. Our outside function, our h of x, or I'm sorry, that would be our f of x, would be the power to 1/2. So how do we take the derivative of that? Well, we drop the power down in front, power goes down by 1. Stuff stays there, but we have to multiply by the derivative of the stuff. So we're going to multiply by 2x. Okay, let me say that again. The outside function is our power function, the 1/2 power. Just like any other power function, power drops down in front, power goes down by 1, stuff stays there. But then we have to multiply by the derivative of the stuff. So identify what's in the outside, what's captured on the inside. The inside is your stuff. Leave it there. Do the normal outside function like we know it. But you have to remember to leave it there and then multiply by the derivative of the stuff. Does everybody see how I did that? Leave the stuff there, do the normal outside function, but then multiply by the derivative of the inside. Okay, let's look at this one. What we have learned so far about this, we now could do it using the quotient rule, or we could use a power rule. I'm going to use a power rule. I'm going to rewrite this as 3x squared plus 1 to the negative 2 power. This is my stuff. 3x squared plus 1 is my stuff that has been stuck inside. This is my outside power, my outside stuff, my outside function. What's on the outside? A negative 2 power. So to take the derivative of this, we're going to do the outside stuff first. It's a power rule. Power drops down in front, power goes down by 1. Power drops down in front, power goes down by 1. The stuff stays there, but then I also multiply by the derivative of the stuff. That's the chain rule. If something is stuck inside, you evaluate it twice. Once for the outside function, leave the stuff there, then times the derivative of the stuff that's stuck inside. Makes sense, kind of, maybe a little bit? Okay, let's do some more. Now, there's going to be times where we come across a combination of our rules. Put a dot between them. Now, the reason I want to put a dot between them is I want to think of this as first times the second. Now, I have to do the product rule. First times the derivative of the second, which is a chain rule, plus the second times the derivative of the first, which is a different chain rule, okay? So our function is going to be the first. I'm just going to write the first quantity, 2x plus 1 to the 5th, times the derivative of the second thing. Now that's a chain rule because it's a power on the outside, a thing on the inside. Stuff is stuck in the inside, power of 7. 7's going to drop down in front. Power is going to go down by 1. Stuff is going to be there, but then I have to multiply by the derivative of the stuff. So that is just the derivative of our first. You take the derivative using the chain rule because it's something stuck inside of something else. The derivative of the inside always is your last step, okay? Plus the second as is, no changes, times the derivative of the first. So I'm going to drop the 5 down in front. Power's going to go to a 4. I'm going to leave the stuff there, but I have to multiply by the derivative of the stuff inside. So it has a 2. So that's the derivative of our first. I had those totally mixed up, didn't I? Well, that's the rule we're using, yeah. Yeah, I don't need you to simplify it at this time, yeah. Well, then that's it. Now, yeah, let's do a few things together for just a minute. No, you don't. I don't think we have to. I think you're good. Yeah, because those are just power rules for now. See how it's 3, 6a, and then we'll do some with trig functions tomorrow. Okay? So do your thing, do your thing, do your thing.